So what does microscopic mean? Anybody have an idea what microscopic means? Okay, so you think it's something small. How small is microscopic? Microscopic is something that's so small you have to use a microscope to see it. Okay, it's so small that you can't see it with just your eyes. So is an ant microscopic? He's really small. Okay, but you can still see that ant with your eyes. An example of something microscopic might be bacteria, an atom. Something is so tiny you have to have a microscope to see it. Then we're talking about the opposite of microscopic. That word is macroscopic. So, the trees outside, microscopic or macroscopic? They are macroscopic. You don't have a microscope to see them.
And how do we know there aren't any horny toads? Well, mainly because we don't see any evidence of them. But do you get to see every animal you want when you go walking outside? No, they're not always there. But what can we do to tell that animals are? We can look for evidence of animals. And we have some evidence right here. What do you think that is? Okay, the white material on the grass here is the droppings from a large bird. Those are pretty big droppings. And there's a branch up here that it was probably sitting on. And if we look down below here, we can see some bones, which probably makes it a raptor, an owl or a hawk. These bones probably came out of an owl pellet or something like that. This here looks like a pelvic girdle off a rodent. We've got a scapula here, and we have the jawbone with teeth. Pretty good evidence that somebody was eating rodents.
We're going to talk about one particular adaptation of these plants. They are, for the most part, halophytes. Halophytes literally means salt-loving, but no plant loves salt. So a better term for that would be salt-tolerant. So the plants you see here have many adaptations, but salt tolerance is one they have to deal with on a daily basis. This land at any given moment can be inundated with fresh water after a big rain event, or if there's a tropical event, it may be inundated with salt water. The soil is always saturated with salt. The plants out here are very shallow rooted because the soil is wet. Oxygen doesn't get down into the soil very well. Plants, just like animals, need oxygen. But when the roots go down to grab the water, they can't separate salt from the water.
Let me explain real quickly the difference between turbidity and salinity. When you're measuring salinity, you're measuring minerals that are dissolved and anything else that is dissolved in the water, okay, that you can't see. When you measure turbidity, you're looking for the undissolved solids in the water. Now, why are undissolved solids in the water important? Well, a lot of what the beasties, the animals that live in the pond will eat, the smaller animals will eat, will be what's floating around in the pond. That's turbidity. That's a floating, undissolved stuff in the pond.
Well, it's a lot more fun to play with the wet flume. What we have set up here is a tank of water and sand, and we've got an artificial river that we've made. And right now the water level is really high, and you'll notice our river is meandering across the floodplain, not unlike the Nueces River meanders across its floodplain today. So one of the things that we want to look at is how does the river change and how does the landscape change if we begin to lower our sea level like what happens during an ice age or what happened during the last ice age, and we perhaps increase the river flow just a little bit, I think we're going to see some exciting changes. And so I'm going to reach over here and I'm going to turn a valve and we're going to start to lower sea level.